This video is going to show you how to find the location of an image from an object that's placed between the focus and the front of a mirror using the ray tracing process. This is only an approximation, so we're not going to rely on the shape of the curve of the spherical concave mirror, but instead we're going to draw a vertical line that's perpendicular to the principal axis at the front of the mirror. That's going to be where everything's going to bend, so we draw it until it touches that. When I'm drawing my rays, I'm not going to draw a ray for anywhere but the top of the object. I don't need to do a ray for the bottom of the object, because when I draw my image, it's also going to be at the bottom of the object, since the bottom of the object is right along the principal axis. So just the top of the object. First one, incident ray, is going to be parallel to the principal axis and reflected through the focus. Parallel until I get there to the front of the mirror, and I'll put a little dot there. And then the next part is going to go from this point where I put the dot down to the focus. So I'll put a dot there. When I connect the dots, I'll draw a line that's extended on both sides of the mirror. On the left side where the light belongs because it's reflected to the left, and on the right side where there aren't any photons. The right side is called the virtual side, where the photons don't belong, where they don't go. So that's our first ray. Now let's look at our second ray. The second ray is reflected off the vertex or the center of the mirror, again from the top of the object down to the center of the mirror, and I'll put a dot there. Now when I reflect this, you got to remember that the incident angle of light is equal to the reflected angle of light, and we're going to measure the angle from the ray down to the principal axis. So right there is the incident angle. If you look at this, it kind of makes a triangle. So to figure out how to make an angle equal size on the other side, it's almost like just flipping my triangle over. Or an easy way to look at that is measure the height of the object. You can use a ruler or a piece of paper, whatever you need, and then you go directly down underneath the principal axis and put a dot at the height of the object if it were upside down under the principal axis. Then I'll connect my two lines, and there's my reflected ray. I also know by doing this, my two angles are going to be equal. Now it's important to take your time and be precise and use a ruler when drawing the lines, or your lines are not going to cross anywhere close to each other. And they're not going to be perfect because it is an approximation, but they'll be pretty close. Next ray, I'm going to draw from the object's tip through the center. Here's the tip where the dot is, and the next dot I'll put on the center, and then I'll just connect these two with a line. One line. The incident ray and the reflected ray are on top of each other, and again, I'm extending my ray all the way over to the virtual side where there are no photons. This is an approximation for a spherical mirror, so think about this as being inside of a big shiny sphere. If it was, the light would bounce back and forth on top of itself through the center, and that's why the ray goes one ray on top of itself. Last ray is now to draw this one, it's the reverse of the first one. The first rule was parallel to the principal axis and reflected through the focus. This one's through the focus and reflected parallel to the axis. So what I'm going to do is use the point of the focus as kind of a location to help me aim a line that goes from the focus to the tip of the object until I reach my dotted line on the mirror. And then I'll put a dot there, and that reminds me that that is where I need to now draw the parallel line. So here's the parallel line. So there are your four rays. At this point, your paper probably looks something like this. If you've been careful and you've used a ruler to draw your arrows, you've probably noticed something like mine where all the arrows or all the reflected light rays are not meeting up where the light or all the photons are on the left side of the mirror. They're actually meeting up on the right side where there aren't any photons. So this is the virtual side. And my image, that's the tip of the image where they all line up. And remember, the bottom of the image is on the principal axis. So I know that my image is going to go from the bottom to the top. And when you're drawing your arrow as the image, make sure you also draw an arrow, not just a dot where they meet, that goes from the principal axis all the way up to where the arrows meet, or the reflected light rays meet.